All right, first 6 are about properties. You need to be able to identify the properties. I will be glad once again to put the names of the properties up on the board, and they will be commutative, associative, distributive, inverse, and identity. And you will not be required to say the associative property of addition, just associative property, and you can abbreviate if you'd like. Okay, so problem number 1 has 7 plus parentheses 24 plus 25, close parentheses, equals parentheses 7 plus 24, close, plus 25. And I kind of ran right into the properties. So what do you see from the left side to the right side? What do you see that's different? Grouping, and that tells you it's which property? Associative. When the groups change, it's associative. Number 2 has 6 plus negative 6 equals 0. What is the relationship between 6 and negative 6? They're inverses, and that is an inverse property. Number 3, 9 plus 0 is equal to 9. And what is the relationship between 9 and 0? 0 is the identity. Number 4, I have 1/3 times 3 is equal to 1. We're dealing now with multiplication, but what's the relationship between 1/3 and 3? Inverse. Those are the multiplicative inverses. Number 5 has 3 parentheses x plus 2 is equal to 3x plus 3 times 2. What have I done when you look at the left side and the right side? That's distributive. And number 6, I have 4 times 7 is the same as 7 times 4. Commutative. The numbers have commuted or switched positions. There will not probably be 6 of those on the test. There'll just be maybe 3 or something like that. Any questions on properties? I will provide the list, but I might need to be reminded to do that. All right, the next group asks you to solve some equations. So we're going to have a whole set of solving equations. I will show the steps. I may or may not use a lot of color in this because I'm trying to go through this entire review, I guess, kind of rapidly. All right, I have 3 parentheses, x plus 3 is equal to, and I don't know why this is in parentheses, but it has 3x plus 9. And I am supposed to solve that. Those of you at the back of the classroom, can y'all see that okay? Okay, all right. All right, I've still got my barrier if you want to draw that. I'm going to simplify on the left and simplify on the right. On the left, I use the distributive property. That's going to give me 3x plus 9. And on the right side, there really was no reason for parentheses. That's 3x plus 9. Now, you might know what the answer is right now. But if not, you could say, well, I have variables on both sides. I need to get rid of one. So I'm going to subtract 3x, subtract 3x. What happens is, not only does it disappear from the left, but it disappears from the right. You're in one of those special cases. When you have the variables disappear and you're left with a true statement, what's the answer? Okay, all reals. This was a math lab question. You would have answered just letter R.
Will you kind of prove it true?
I possibly will, because true is an assessment of what's going on, but it's not the answer to the question. Because the question really is, what number can go in the place of x and make this true? And so the word true can't be the answer. It would have to be all real numbers. Okay? I might feel mercy and give you credit, but I would rather you respond with all real numbers. Number 8, I have 6 parentheses, 2x minus 1 is equal to 24. Distributive property on the left-hand side, that's going to give me 12x minus 6, and that's equal to 24. I'm going to add 6 to both sides. I end up with 12x is equal to 30. What's my final step? Divide by 12. And it does not go in evenly, so all you need to do is reduce that fraction. What will go in to both 30 and 6? I'm sorry, 30 and 12, 6, okay. How about 5 over 2? I would accept the decimal version of that, 2.5, but if it's a repeating decimal or if it's a non-terminating decimal, you'd have to round it to write it down, and then you've changed its value. So I really would prefer the fraction. MATLAB would have required it.
When I had worked this over the weekend, I actually reduced it to 2.5. Is that also?
That's also, yes, absolutely. So I'm going to be very flexible in the form of the answer I accept, where MATLAB is never flexible. And as far as that projection turning blue on the screen, I have no idea why that happened. And it'll go back to white in a little bit. All right, I have 3 parentheses, x plus 4 plus 68 is equal to 7x minus 4 parentheses, x minus 6. All right, on the left side, I need to simplify. So I'm going to use the distributive property and get 3x plus 12 plus 68. Then I'm going to combine like terms, and I have a 12 and a 68, which add up to be 80. So I have 3x plus 80. On the right-hand side, when I distribute, I'm going to distribute, and I have to be careful, a negative 4. So I'll keep my 7x. Negative 4 times x is negative 4x. Negative 4 times negative 6, positive 24. On the right-hand side, my like terms are variable terms. 7x minus 4x is 3x, and I have plus 24. Now this one was pretty well disguised. It's time for me to take care of variables on both sides. When I subtract 3x, I end up with 80 is equal to 24. This time, variables dropped out, left with a false statement. What's my answer? No solution. I think when you did these in MATLAB, you used capital letter N. All right, problem number 10. I have 0.05y plus 0.10 parentheses 900 minus y is equal to 0.45y. Now, this is an option. You can do this if you want. Since each of the terms has the decimal in it, hundredths, 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 I can essentially multiply by 100, and what that does is move the decimal point 2 places in every number. If you don't want to do this and you just want to leave the decimals in your problem, absolutely fine. This one then turns into 5y plus 10 parentheses 900 minus y is equal to 45y. I didn't multiply and move decimals inside the parentheses because the distributive property will carry that inside. So I end up with 5y plus 9,000 minus 10y is equal to 45y. I can simplify a little bit more over here on the left-hand side. I have 5y minus 10y, which is negative 5y plus 9,000 is equal to 45y. Now I've got variables on both sides. You can get rid of either one. Since I want variables to get together and leave constants to the other side, my choice, and it is just a choice, is to add 5y to both sides. That's going to give me 9,000 is equal to 50y. Last step, divide by 50, and y is equal to how much? 180. And by the way, I'm doing these and I didn't even grab a calculator. I'm dependent on people giving me help with calculations. But if I make a mistake and you've got the solutions there, please call me on it so I won't leave that in this recording. Once again, it is optional in the first step if you want to move the decimals or not. And I can't remember when I did the solution whether I did that or not because it doesn't. Yes, I did. Okay. So if you looked at the printed sheet of solutions, I've done exactly the same thing. All right, let's look at 11. Number 11 has some fractions in it. I have 2x over 5 minus, x over 3 is equal to 2. What do you do to make an equation easier when there are fractions in it? Multiply by the least common denominator. What's the least common denominator for 5 and 3? 15. So I'm going to multiply 15 times 2x over 5 minus 15 times x over 3 is equal to 15 times 2. Now, I need to simplify each one of those products. A little bit. All right, the 15 is really over 1, so what happens? 15 goes in there once, 5 goes in there once, 5 goes in there 3 times. 3 times 2x is 6x minus. The second red 15 is over 1. 3 goes in there once, 3 goes in there 5 times. I have 5 times x for minus 5x. I have an equal sign. There aren't any fractions on the right-hand side, so I just multiply for 30. On the left side, I'm going to simplify. 6x minus 5x is x equals 30. Problem done. So when you have fractions in an equation, identify the least common denominator and then multiply each one of the terms by it. That will allow you to cancel out your denominators. Problem number 12. I have 3/2 x plus 7/3 is equal to 4/3 x. I'm going to take the sneaky route here. Would y'all tell me what the common denominator is? 6. I've sort of left enough room, and I'm just going to sneak my 6 in because it gets to be a challenge rewriting and switching between black and red. So I'm going to sneak in that 6. Each one of those 6's can be put over 1 if it's multiplied by a fraction. So the first one, 2 goes in there once, 2 goes in there 3 times. 3 times 3 times x is 9x. Plus, the second red 6 is over 1. 3 goes in there once. 3 goes into 6 2 times. 2 times 7 is 14. There's no x in that term. Equal sign. The last 6 is over 1. 3 goes into itself once. 3 goes into 6 2 times, and I get 8x. Now, it is always your choice when you have variables on both sides which one you want to get rid of. So which one would you like me to get rid of? 9x? All right, I'm going to subtract 9x. That gives me 14 is equal to negative 1x. And you might not write the 1, but it is negative x. Divide by negative 1, and negative 14 is x. Any questions? Please stop me if you have a question. I'm probably moving pretty fast. I hope it all feels like review. Number 13 is the last of the equations to solve. At least that's all, the last in this group. I have b over 12 minus 3 is equal to negative 1. And once again, I left a little space so that maybe I can do this the easy way. I see a fraction. What's the common denominator? 12. So I will multiply 12 times the first term, 12 times the second term, and 12 times the term on the right-hand side. I have 1, 2, 3 products. If you're multiplying that least common denominator times a fraction, then of course you need to put it over 1. Those 12s divide out, and you get b. The other terms are not fractions, so all I do is multiply. I have minus 36 is equal to negative 12. I want the b by itself. There aren't any b's over here, so I'm simply going to add 36 to both sides. And I get b is equal to 24. The next ones ask you to solve inequalities. And it says leave your answer in inequality notation. Now, in the past, this was actually on your very first test in here, you had to answer the question 3 ways. You had to write it as an inequality, like x is greater than 2. Then you had to draw it on a number line. Then you had to write it as an interval. On this test, all you have to do is write it as an inequality. So let's look at number 14. I have negative 6, parentheses, 4y plus 6, close parentheses, less than negative 30y minus 24. My barrier still exists, but it exists where the inequality symbol is. All right, I'm going to simplify on the left, distributive property. That gives me negative 24y, and negative 6 times positive 6 gives me negative 36. Keep my less than symbol, negative 30y minus 24. Now I have variables on both sides of the inequality. I choose to add 30y to both sides. That will give me 6y minus 36 is less than, those are gone, negative 24. I'm going to add 36 to both sides. 6y is less than 12. It's time to divide. I divide by 6, divide by 6. Nothing happens to the inequality symbol because I'm dividing by a positive number. What happens if the coefficient of the variable is negative, which means I divide by a negative? It flips the symbol, reverses it to go the other way. That doesn't happen in this problem. So y is less than 2. And you don't have to do anything else to the problem, even though we did when we tested on this the first time. All right, let's look at 15. I have negative 12x plus 3 is less than or equal to negative 3 parentheses 3x plus 2. The left-hand side doesn't need any simplifying, but the right-hand side does. So I'm going to distribute a negative 3 keeping the symbol. That'll give me negative 9x, and it'll give me minus 6 on the right-hand side. And the left-hand side stays as it was. I have variables on both sides. When I do inequalities, I really like the variable to end up over here on the right-hand side. So I'm going to add 9x, That gives me negative 3x plus 3 less than or equal to negative 6. Subtract 3, negative 3x less than or equal to negative 9. And my final step, divide by negative 3. Because it is a negative number, that causes the inequality symbol to flip over. So now it's a greater than or equal to, and I have x is greater than or equal to 3, because a negative divided by a negative is a positive.
I did plus 12.
Mm-hmm.
And I didn't have.
Correct. I bet that your answer, because you got the variable on the other side, I bet you have 3 is less than or equal to x.
Right.
And that's absolutely fine. There's nothing wrong with that. My concern about that form of the answer, not on this test, but just in general, is that if you had to graph this, if you put your variable on the left side, then the arrow always goes in the direction of the inequality symbol. If I graphed this and I located the 3 and I use the bracket, it goes this way. You can get pretty easily misled if you have it written the other way. But there's nothing wrong with it. You write that on the test, you get full credit. Okay? All right, so that's it for inequalities. Now we have some word problems. It would be helpful if you have these written down in front of you, but if not, I'm going to read them. I'm not going to write them. It says 30 marbles are to be divided into 3 bags so that the second bag has 3 times as many marbles as the first bag, and the third bag has twice as many as the first bag. Did you notice those comparisons and that both times the first bag was not identified? Let's see. The third bag has, I'm sorry, I'll find it here. The second bag has 3 times as many as the first. Don't know about the first. And the third has twice as many as the first. Still don't know about the first. Now, let me just say one thing. The first time you encounter word problems on the final, they are to be done with one variable only, just x. This comes from our very first test back in chapter 2. So I will let x be first bag. All right, the second bag has 3 times as many. How will you write an expression for the second bag? 3x. Yes, 3 times as many is 3x, and that's the second bag. And then it says the third bag has twice as many as the first. So 2x. All right, and it tells you to use x for the number of marbles in the first bag. Find the number of marbles in each bag. Well, I have a comparison. I have lots of comparisons that helped me write those. Now, what's the only other fact that's in the story? There are 30 marbles. The total is 30. The sum is 30. So x plus 3x plus 2x is 30. And now it's time for me to solve this. All right, I have 1x plus 3 plus 2 gives me 6x is 30. Divide by 6. X is 5. Now that's the number of marbles in the first bag. How many will be in the second bag? 15. So it'll be 3 times 5 or 15. And in the second one, I can't say it right. In the third bag, it's 2x, so it's 2 times 5, which is 10. So your answers are 5, 15, and 10. Okay? Please give me all 3 answers. All right, 17. It says the sum of 4 times a number and 3 is the same as the difference of twice the number and 11. Find the number. So there is a mystery number, x. X is the number. Now, I'm going to read, I'm going to write. When I get to the verb, probably an is or is equal to, I'm going to put my equal sign. The sum of, all right, sum of, I'm ready to do some addition. The sum of 4 times a number, 4x, and 3, put in my 3, is, equal sign, the same as the difference of, okay, difference. And by the way, difference of is not a reversing phrase. Less than reverses, subtracted from reverses. Difference does not. The difference of twice the number, 2x, and 11. Okay, so now I need to solve that. I have variables on both sides, so I'm going to subtract 2x. That gives me 2x plus 3 is equal to negative 11, so make sure you hang on to that negative sign. Subtract 3 from both sides. I have 2x is negative 14. Divide by 2. X is negative 7. If you get the translation right, the most common place for a mistake would be forgetting to carry down the negative sign with 11, and that would certainly change the answer. Questions? Okay. Number 18. Still only using one variable. We had not learned about systems at the time that we did these word problems. And the test is created chronologically from the first thing we studied to the last thing we studied. All right, the president of a certain university makes 3 times as much money as one of the department heads. Which one do you know nothing about? The president makes 3 times as much money. Right, so X is going to represent the department head. The president makes 3 times as much, 3x. If the total of their salaries is $170,000, find each worker's salary. How will I write an equation from that information? Total means to add. So x plus 3x is 170,000. I'm going to combine like terms on the left. That gives me 4x is 170,000. Divide by 4. And x is equal to 42,500. Is that correct? Okay. And what did you just find? The department head salary. The president is 3x, so it's 3 times 42,500. Or you could have subtracted 42,500 from the 170,000. And the president's in pretty good shape. 147. Oh, thank you. Poor guy. 127 and 500. Uh-oh, stop that. Okay, it just has little problems sometimes. Real quickly before it decides to come back. All right, so in this problem, you would have 2 answers. Is that okay? All right, problems 19 through 22 ask you to find the slope of a line. So this is a case when your blue sheet might be helpful. Problem 19 asks you to find the slope and it gives you 2 points. 5.8, and 9.3. To find the slope given 2 points, you need to have the slope formula. My version of the slope formula is y1 minus y2 over x1 minus x2, although you're welcome to use it with the 2's before the 1's. The y's are on top and the x's are on bottom. So that will give me 8 minus 3 over 5 minus 9. That's 5 over negative 4. And you can stop the problem right there. You certainly could have that negative sign with the top instead or out in front of the whole fraction. But I just leave it where I get it. Any questions on slope formula? It's on your blue sheet. If you've lost your blue sheet, you can print one off of my math lab under handouts. I will be walking around the classroom to look at your blue sheet. If you have added anything to it that I have not specifically said is okay to add to it, then you need to make sure you print yourself a clean one, because you won't be allowed to use one with writing on it. I don't know if we've added anything to it, but if we have. All right, number 20. I have x equals negative 3. That's the equation of a line, and I'm supposed to determine the slope. Would you tell me what you know about the line x equals negative 3? Pardon? Okay, one person says it's horizontal. Somebody says it's vertical. Which axis does it cut through? The x. In order to cut through the x-axis, you have to be a vertical line. So this is a vertical line, and so you can envision a vertical line. You don't have to write that down. You don't have to graph it, but this is the line cutting through the x-axis at negative 3. What is the slope of that line? And I'm seeing some negative head nods. There is no slope. I think it's usually called undefined. Remember, think about skiing. It is impossible to ski on a vertical wall. So that's why we can say it is undefined. Number 21. I have y equals positive 3. Tell me what you know about the equation, the line, y equals 3. It is a horizontal line cutting through the y-axis at 3. You don't have to draw it. I'm just doing that so that we can see it. What is the slope? 0. And perhaps you remember me making fun of myself, saying that I did a lot of that when I was skiing, laying flat on the ground, and I was a 0. All right, 22. We have 11x plus y is negative 4. Now, these 4 questions on slope really do cover the things we did. Slope from 2 points. Then the slope of the 3 different kinds of lines that can exist. Vertical lines, horizontal lines, and now a slanted line. What form does a slanted line need to take on in order to figure out its slope? Yes. Y equals mx plus b. So I need y equals mx plus b so that then I can grab the slope. I need to solve this for y. What will I start out doing? Subtract 11x, and I get y is equal to negative 11x minus 4. The answer to the question should be staring at us. The slope of the line is negative 11. It is not negative 11x. It is just the number negative 11. Any questions on finding slope? All right, the next 3 questions are graphing. And like I had told the class, I don't have good graph grids available, poor planning on my part, so I will just be sketching these lines. And you're probably doing the same thing. Number 23, I'm supposed to graph y equals 5. This one won't be too bad. Would you tell me what you know about the line y equals 5? It is horizontal. It cuts through the y-axis at 5. So 1, 2, 3, 4, 5, cuts through there, and that's all it takes to get that graph done. Number 24. I have y equals negative 1/2 x plus 2. This one's in slope-intercept form, isn't it? You may make a t-chart if you wish. You may find the intercepts using x is 0, y is 0, or you can use slope-intercept. Totally your choice. I think I would like to use slope-intercept since it's already in y equals mx plus b form. Where will I begin? 2 on the y-axis. So I'll go to 2. Let me put a few little tick marks on here. All right. How will I move? Down 1, right 2. So when I took the 1/2, I chose to attach this negative sign to the numerator. So that would tell me down and right. The numerator's the vertical change, the denominator's the horizontal change. It is rise over run. So from this beginning point, I go down 1, right 2, and draw another point. Down 1, right 2, another point. Straight edge would be a good tool to have, but I've just drawn a little wiggly line. My slope is negative. Does that match my line? Do I have a falling line? And you might take a moment to think about that. Last problem in graphing is number 25, and I have negative 4x minus 20y is equal to 20. Now, you may, if you wish, solve this for y equals to get it in slope-intercept form, or would you like me to do this one a different way? This turns out to be a pretty easy problem to do by intercepts. If you'd like me to do it twice, I'll be glad to do it twice. But intercepts appeal to me on this problem, and intercepts say that you start out that way. If x is 0, then I have negative 4 times 0 minus 20y is equal to 20. That term is 0, so I have negative 20y is equal to 20. Divide by negative 20. Whoops. And y is equal to negative 1. The y-intercept is the point 0, negative 1. When y is 0, I have negative 4x minus 20 times 0 is equal to 20. That term goes to 0, and I have negative 4x is equal to 20. Divide by negative 4, and x is equal to negative 5. That's the x-intercept. Any questions on the calculations? All right. If I were to draw this little coordinate plane, and graph my line, I'll do it in blue this time, 0, negative 1. Starting at the origin, I go 0 in the x direction, but down to negative 1. For the x-intercept, I go to negative 5, but I don't go up or down. So there are my 2 points, and there's my line. Does anybody in the classroom want me to do this in slope-intercept? Okay, let's take a look at it slope-intercept. I'll come back to this same graph when I do that. All right, the equation is negative 4x minus 20y is equal to 20. Let me label this. If I'm going to do it in slope-intercept form, then I need y equals. So I'm going to add 4x to both sides. I have negative 20y is equal to 4x plus 20. Those were not like terms, so I couldn't combine them. Divide by the coefficient, which is negative 20. Now, I see that I'm going to get a fraction, but I'm not really worried about it because that fraction is going to be the slope. And I don't mind the slope being a fraction. I like it. Y is equal to. Can you help me reduce that fraction? What goes into both 4 and negative 20? 4. 4 goes into itself once. 4 goes into negative 20, negative 5 times. And I have my x. And then 20 divided by negative 20 is negative 1. All right, now what does that tell me? Where do I begin? Negative 1. And how do I move? Up 1. And the way I have it written, left 5. So go back up to the graph, and you can see that I begin at negative 1, and I already had a point there. The slope moving instructions tell me to go up 1, left 5. And did I end up with exactly the same thing? So I'm okay. So you are welcome to graph it in any way you want. Go back to black. On the review for the final, you are asked to solve 2 systems by graphing. I know there will be only one on the test, but we've got a little extra practice to do. All right, number 26, I'm supposed to solve this by graphing. So I have 3x plus y is 10 for one of the equations, and 2x plus y is 7 for the other one. I'd like to use slope-intercept if y'all don't mind. And this is going to be really bad example because I don't have a grid, and you should never try to solve by graphing without a nice grid. But I'm just going to do it anyway. All right, I'm going to subtract 3x, and I have y is equal to negative 3x plus 10. I will begin at 10, and I should move, I have negative 3 over 1, which is down 3, right 1. Now that could be a little problem on a grid because usually, oh no it won't, that's positive 10, so that's okay. I was thinking it was negative 10 and I'd be moving right on off the grid. And you can adjust if you have that. All right, second equation, I'm going to subtract 2x. And I get y is equal to negative 2x plus 7. So where do I begin? 7. And I move negative down 2 and to the right 1. All right. Like I said, I am demonstrating bad behavior up here by not using a real grid because what are the chances that I'm actually going to get to the right point of intersection? And I will tell you that I am cheating and I'm looking at the answer to try to make it happen. Yes? No, it won't, but thank you. That's actually what she's showing me a paper grid, and if I were using the document camera, it'd be perfect. But here, I had to have thought about it before I was doing this to pull the grid in. And so I messed up. 3, 4, 5, 6, 7, 8, 9, 10. Okay. So here goes bad graph. The first one I'll do in blue. I am supposed to begin at 10 and move down 3 blocks, right 1. And I could continue that. And get a line that looks something like that. Okay, really bad. Didn't even bother to use a straight edge. I'm being so inaccurate right now. All right, the second line, which I will do in red, begins at 7 on the y-axis. From there, I move down 2, right 1, down 2, right 1, down 2, right 1, if I did this correctly, if I had a straight edge and I did all the right things, they would intersect at the point. Cheating going on here. I made it happen. They intersect at the point 3, 1. So you're going to want to be careful, and I'm going to want to be somewhat forgiving when I grade this because the grid's not huge on the test. So I need to see you get into a decent neighborhood and make a decent assessment of what the answer is. And some of you may have thought I was real picky when you were testing over this, because if you leave off the point, then you've not answered the question, which was solve this by graphing. I want you to tell me what the point of intersection is. So you have to label the point. Okay, that was number 26. Any questions on that one? Hmm? 27. The system is x plus y equals -3 and x plus y equals -6. I'm going to use slope-intercept again. Subtract x, y is equal to -x minus 3. Where do I begin? -3. The slope is -1 over 1, down 1, right 1. Second line, I'm going to subtract x, and I get y is equal to -x minus 6. I begin at -6, and I move -1 over 1. Even if you come up with the conclusion immediately, please go ahead, if this is your problem, and comply with the instructions which said do it by graphing. I hope that maybe you're noticing that this slope value and this slope value are the same. Okay, so if I all right, first line in blue, I begin at -3. From that point, I go down 1, right 1, and I'm just going to jump right in there and draw a line. Not a great line, but a line. Second line, it says to begin at -6, which is down here, go down 1, right 1, which would put me about there. If I had used a straight edge and a good grid, it would be very obvious that these are parallel lines. What is the answer that you give me? No solution. So I need the conclusion. Oh, goodness. Okay. So please give me the conclusion. What kind of graph would you get for the answer to be all real numbers, or I'm sorry, infinite solutions? The same line, when they turn out to be coincidental. One line sits on top of the other line. All right, we're through with graphing systems, and it should sort of feel like we're moving through the course that it took us 5 weeks to do, and I'm trying to do it in less than 2 hours. All right, the next 2 questions say, solve the system of equations by either addition method or substitution method, and it is totally your choice. Problem 28 has the system x is equal to -8y minus 34 and -4x plus 7y is -59. Your choice. Does this system look like it's ready for addition or substitution? I agree substitution, because the top equation says x equals. So I will circle that and I'll put it in the place of x. That's going to give me -4, parentheses, instead of x, I put -8y minus 34, close, plus 7y is negative 59. Did you see the substitution take place? All right, I'm going to simplify a good bit on the left-hand side. Distributive property first. That gives me 32y plus 136 plus 7y. Can I simplify more? Combining like terms, I have 39y plus 136. And all of that is equal to negative 59. I'm going to subtract 136, and somebody please add for me. Okay, I have 100, and it is negative 195. Divide both sides by 39. I would like a divider, please. And y is equal to? Does it not go in evenly? 5. And it should be negative 5? Okay. So the y value is negative 5. Am I through with the problem? No. So I have to now find x. I will be thinking about this circled expression that's up here at the top. X is equal to negative 8y minus 34. X is equal to negative 8y minus 34. Plug in negative 5 for the y value. X is equal to negative 8 times negative 5 minus 34. X is equal to positive 40 minus 34. X is equal to 6. My answer is 6 comma negative 5 as an ordered pair. So we have solved that system. Let's look at the next one, number 20. 9. A little slow on the 9 part of that. I have 2x plus 5y is 18, and I have 4x minus 2y is negative 16.8. Now you have your choice of doing this either by substitution or addition, and it's not ready for either one of them. Because this is a review session, no matter what I might choose on my own, I'm going to do it by addition. If I look at the x's, what's the least common multiple of 2 and 4? 4. 4 is the least common multiple, and I'll write that down. I would only have to change the top equation to make those be both 4s. What's the least common multiple in the second group? 10. And that would require me to change both of those, and so I'm not going to do that. I'm going to do what it takes to get a pair of opposites with the x's. And what I need to do is multiply that top equation by negative 2. So negative 2 times 2x gives me negative 4x. Negative 2 times 5y gives me negative 10y. Equal sign. Negative 2 times 18 is negative 36. I'm going to copy down the second equation. 4x minus 2y is negative 16.8. And do what the name of the process is, which is addition. I've made the x's be opposites. I have negative 12y is equal to negative 52.8. Is that correct? Divide by negative 12. Don't freak out because you're going to get a decimal. 4.4. Okay, and it's positive because it was negative divided by negative. Okay, so because that's happened to you on the review, if a similar question like this shows up on the exam, don't be surprised if you get a decimal. I'm not quite through because now find x. Not quite as straightforward as it is with substitution. Which equation are you going to pick? Any that you want? I'll just pick the first one. I pick 2x plus 5y is 18. And I'll plug this in for y. and I have 2x plus 5 times 4.4 is equal to 18. Oh, I do that so much. All right, 2x plus 22 is equal to 18. Subtract 22 from both sides. I have 2x is equal to negative 4. Divide by 2, and x is negative 2. The answer to my system is negative 2, comma 4.4. Is that okay? All right. Now we have some word problems, but we have just done systems, so these are going to be word problems by systems. And because you've already solved systems, although it doesn't say it on here, all I'm going to ask you to do is set up the system, just like you did on your test. But I'm not going to do the extra credit thing. Okay, so just set up the system. Number 30. It says one number is 4 less than a second number. Twice the second number is 10 less than 5 times the first. Find the two numbers. So you have to make a decision. Systems means two variables. So I'm going to have x is, I'm going to call it the first number, and y is the second number. One number is. That means x is. This is literal translation. You read it, you write it. 4 less than the second number. Do you remember the phrase less than means to reverse? 4 less than the second number. How will I write that down? Y minus 4. So remember that less than means to reverse. Okay? The second one. Twice the second number, 2y, is equal sign 10 less than, so I'm going to subtract 10, 5 times the first, 5x. And although the answer sheet does not have that, it has the actual solutions. All you have to do to get credit for the question on the test is to create the system. Because you've already proven to me in previous problems that you know how to solve it. Is that okay? And a key there is the phrase less than. 31. It's a chemist. It's your last mixture problem. All right. A chemist needs 160 milliliters of a 40% solution, but has a 26% solution and a 58% solution. How many milliliters of each should be mixed together? So I like to do the beaker thing. As far as percentages, I have a 26%, I have a 58%, and I need a 40%. Now I need to go on the outside and talk about their volume. I need 160 milliliters. The question is, how much of each of the others do I need to add together? So what am I going to call them? X and Y. So 2 equations to create a system. On the outsides, what could be the first equation? X plus Y equals 160. The second equation involves the percentages, and I'm skipping steps. Percentages get changed to decimals, but then I move the decimals back in the equation, so I just wave my hands and say I'm not doing all that. It's going to be 26x plus 58y equals 40 times 160, and you don't need to multiply that out to get credit. You can leave it just like that. There's your system. I am not going to take time to solve it because you don't need to.
So we won't solve these two?
You will not solve these two. And hopefully I have that written on your test. I hope the instructions say just set it up. But if they don't, I'll give you verbal instructions to go to your test and write that. Okay? And number 32 needs to be omitted. We didn't do that. And I hope that I made sure that was one of the ones that didn't make it to the test. If I messed up and it's there, then you'll see an X through it, and you'll omit it.
You don't want to just give us credit?
No, you'll get credit for it. Yes. I will not count it wrong. I will delete it. Yes. So you'll start the test out with a 3. Well, actually a 4.
Yay.
Okay, so everybody's got 4 to start with. All right, next we're going to move on to exponents. And this was the information that was on your Chapter 5 test. You have recently taken your Chapter 5 test. Your properties are all on your blue sheet, so you might want to have that out when you're testing. Number 33, it says simplify the expression. Write the result using positive exponents only. Negative exponents, bad form. I have x to the 7th y in parentheses to the 3rd power. My properties are power rule, product rule, quotient rule, and negative exponent rule. And that's the order I like to use them. So, do you need to use the power rule? Yes. So I'm going to let this power affect both of these bases. And what do? Multiply them. So I'm going to get x to the 21st power, y to the 3rd power. Done. Number 34. I have s to the 15th, t to the 4th over s to the 2nd, t. I'm supposed to simplify this. Do I need or can I use the power rule? No. Do I need the product rule? The product would be like bases in the top or like bases being multiplied in the bottom. No. Do I have the quotient rule? Yes. So the quotient rule says to do what with the exponents? Subtract. So I'll have s to the 15 minus 2, which is 13, t to the 4 minus implied 1, which is 3. So I use the quotient rule on that one. 35. I have m to the 4th times m to the negative 6 times m to the negative 5 times m. I'm going to use the rule. I know that we probably all see these negative exponents, and you're thinking, oh, move me. My personal view is, wait, don't move me yet.
Can't you combine them?
Yes, let's combine them. Let's combine them all. Let's use the product rule, because this is a product of like bases. What's the exponent on the last m? 1. So I'm going to get m to the, no equal sign, m to the, I'm going to add 4 plus negative 6 is negative 2, plus negative 5 is negative 7, plus 1 is negative 6. I use just the product rule. Now, can you leave that as your answer? No. This says, please move me. This is 1 over m to the positive 6. So I don't take care of negative exponents till the last step of simplifying. 36. I have z to the 0 plus 11 to the 0. What? Yes. Z to the 0 is 1. 11 to the 0 is 1. And 1 plus 1 is 2. There really should be a little statement that says as long as z is not 0, because you're not supposed to ever raise 0 to the 0 power. But I bet none of us worried about that. No, okay. Everybody okay on your properties? They won't be any harder than that. There was one on your test that was pretty hard, but not here. All right, now we're going to look at scientific notation. Number 37. I have 0.000478. That's scientific notation, that's standard notation. It wants it in scientific, so where will I have to move the decimal point? Between the 4 and the 7. So I will have to move it 1, 2, 3, 4 places. So I know that it's going to be 4.78 times 10 to the -4. Now, why did you choose -4? Okay, small number. When it is a tiny decimal, you use a negative exponent. If it's a big number, you use a positive exponent. Number 38 has a scientific notation number, 5.24 times 10 to the -4th. And maybe it's just a coincidence that these seem to be reverses of each other. This 4 tells me that I'm going to move the decimal 4 places. The direction that you move it should be indicated by whether it needs to get small or large. So I start with 5.24, and which way will the decimal have to go? To the left. 1, 2, 3, 4. Drop the decimal point, fill in with zeros, and then do one final check. Would that number match up with the kind of exponent that you have? Little decimal, negative exponent. Is that okay? All right. The next problems say perform the indicated operation. So this is going to be about polynomials. And problem number 39 is an addition problem. And I'm not going to write it out in two columns in a column like they have it. I'm going to write it out horizontally. I have 5x to the 5th plus 8x to the 4th plus 9x to the 3rd plus 9, close parentheses, plus sign, 7x to the 5th minus 6x to the 4th plus 6x to the 3rd plus 5. What is the rule about addition of terms? They have to be like terms, and like terms have the same exponent, same variable with same exponent. So I'll try to color code these. I have an x to the 5th and an x to the 5th. I have an x to the 4th and an x to the 4th. I have an x to the 3rd and an x to the 3rd. And I have a 9 and a 5 that are constants. And actually, I just had a really good time using all those colors. I really think that's pretty, so it was fun for me. All right, now if I combine those terms, doing some algebra, I have 5x to the 5th and 7x to the 5th for... Okay, you tried to multiply. Okay, we got to stay focused on what our operation is. So it's 12x to the 5th, and the exponent never changes. And so just to be consistent and enjoy my colors a little bit more, I'll make sure that that term matches. All right, plus, then maybe I should have waited. I have 8x to the 4th and negative 6x to the 4th for 2x to the 4th. And that one is my pretty blue. All right, now with the x to the thirds, I have 9x to the 3rd and 6x to the 3rd for 15x to the 3rd, purple, and I have 14 in the constants, a wiggly blue, wiggly green. Is that okay? Mm-hmm. All right. Number 40 goes under the same set of instructions. I'm supposed to perform the indicated operation, and in this one I have 14y squared plus 6 in parentheses and a subtraction, negative 2y to the 4th minus 7y to the 2nd plus 6. Let me scoot that where you can see it better. Not that much. All right. What do we have to remember to do when we have subtraction of polynomials?
Assume the implied negative 1.
Assume the implied negative 1, which is going to change all those signs. Okay, so that's going to give me 14y to the 2nd plus 6. Negative 1 times negative 2 gives me positive 2y to the fourth. Negative 1 times negative 7 gives me positive 7y to the second. Negative 1 times positive 6 gives me negative 6. I'd like to put these in descending order from the high power to the low power. The high power is 2y to the fourth. I don't have any y to the thirds, but y to the seconds. I have 14 and 7 for 21y to the second. I don't have any y's, and my constants are cancel out. They are opposites, so that's all I get. It would not be counted wrong if you didn't put it in descending order. Okay, the next group of questions tells you to multiply some polynomials. And I'm going to do all the different kind of multiplication. I'm going to use distributive property. I'm going to use FOIL. I'm going to remember sum and difference product. I'm going to remember squaring. But it's really, you could make 100 if you remember distributive property and FOIL. All right, number 41. I have x plus 9 times x to the third plus 2x minus 4. And I choose to use distributive property. I'm going to multiply x times each of these. And I'm going to write it down here. X times x to the third, add the exponents because it's a product, is x to the fourth. X times 2x is 2x squared. X times negative 4 is negative 4x. Now, I need to distribute the positive 9. You can put these anywhere you want. 9 times x to the third is 9x to the third. 9 times 2x is 18x. And 9 times negative 4 is negative 36. Combine like terms. Put them in descending order. I have x to the fourth, and he doesn't have any friends to join up with. I have x to the third, which is 9x to the third. X squared. I have a 2x squared. I then have a negative 4x and a positive 18x for, whoops, hang on, a little box has popped up. I need to make it go away. Plus, I hate it when it does this. Okay, I'm back. Plus 14x and then minus 36. Your other option would have been to use vertical multiplication if you wanted to. Very, very similar. 42. I have 4x plus 3 times x plus 11. What kind of multiplication do you think I'll use on number 42? I will use FOIL because it is binomials. So the product of the first, 4x times x, is 4x squared. The outer product, I'm going to go ahead and write it down, is 44x, and the inner product is 3x, and the product of the last is 33. The outers and inners can be combined, so I have 4x squared plus 47x plus 33. Number 43. I have 4p plus 11 times 4p minus 11. What do you notice about this product? It's that positive and negative, which is called the sum and difference product. And what happens with the sum and difference product? Middle term drops out. You don't have to worry about outers and inners. So the product of the first is 16p squared. Don't forget your exponent. The outer product and the inner product are opposites, so I don't care about them. The product of the last is minus 121, and I'm done. You can do it by FOIL and write down those outers and inners, but they will cancel. Number 44. I have 9m plus 1 quantity squared. I'll do this problem twice. If you square the binomial, you square the first one. 9m times 9m is 81m squared. What is easily forgotten is what happens in the middle. You multiply those two for 9m, but then what do you have to do to that? You have to double it. So that will be plus 18m. Square the 1 for 1. If you think, oh, I'm not going to remember that, you are welcome to write it as 9m plus 1 times 9m plus 1. And do it by FOIL. Product of the first is 81m squared. The outer product is 9m. The inner product is another 9m. The product of the last is 1. And when you combine these, it's the same as if you doubled this quantity up here, is 81m squared plus 18m plus 1. Do either one of these, this one or this one. You certainly don't have to do them both. Okay? All right, the next two problems ask you to divide. You have a choice of long division or synthetic division. Number 45. I have 10x squared plus 69x plus 54 divided by x plus 6. And I'll let the class decide. Do you want me to do it by long division or synthetic? My personal choice would be synthetic, and you can do the test questions by synthetic. If you do it by synthetic, what do you do to this number? Make it a negative. You're going to change the sign. So I have negative 6. That goes in the box. I write down 10, 69, 54. All right, synthetic division, bring down the first number, 10, and from then on, it is multiply and add. Multiply 10 times negative 6 for negative 60, add for 9. Multiply 9 times negative 6 for negative 54, add for 0. And remember that that last number is your remainder. So you have a 0 remainder. If the original problem was, the original dividend was x squared, your answer will be 1 degree lower. It will only be x. So the answer will be 10 times x plus the constant 9. It will always be 1 less. And then it decreases by power. Number 46. And I'm looking at my solutions that I did. And I did those synthetically also. That typically is the favorite method. All right, so I have x to the 4th plus 1,296, and I'm supposed to divide it by x minus 6. I'm going to do this one synthetically also, if I could just keep it on the screen. All right, what am I going to divide by? Positive 6, and you have to be careful. I'm going to divide into a 1. Remember, that represents the x to the 4th. Is there an x to the 3rd term? So put in a 0. Is there an x squared term? Put in a 0. Is there an x term? No. Put in a 0. Is there a constant? Yes, 1,296. If you don't put in those zeros, then you will be very far off from the real answer. Bring down the 1. 1 times 6 is 6. Add 0 and 6 for 6. 6 times 6 is 36. Add for 36. 36 times 6 is a big number. It is 216. Add for 216. 216 times 6 is 1296. And that gives us 2592. Now the challenge in this problem is figuring out what the answer will be. If I divide it into an x to the 4th, then what's going to be the power of the first term in the answer? X to the 3rd. So it is 1x to the 3rd plus 6x to the 2nd plus 36x plus 216. You notice I went down by 1 power for each term, plus the fraction 2592 over the original divisor x minus 6. Is that okay? No. Is there a question?
Right now it's great.
Oh, okay. Right now it's great. All right. The last problems are on factoring. So we know that we've got greatest common factor. We've got trial and error, which I'm just going to abbreviate T and E. And we have the difference of squares. And we have grouping. There are more things, more techniques, more types of polynomials to factor, but we don't do them in this class. So problem number 47 has 64k squared minus 49m squared. Which of the types, well, no, let me just start as if we didn't even have that list. Is there a common factor? No. All right, it is a binomial, which means it is difference of squares, if it's factorable, and it is. So one of these is plus and one of these is minus. What is the square root of 64k squared? 8k. So I have an 8k in the first spots. And what's the square root of 49m squared? 7m. So my factors are 8k plus 7m and 8k minus 7m. Problem 48 has a lot of a lot of powers in it. I have 54, x to the 9th, y to the 8th, minus 24, x to the 7th, y to the 6th, plus 18, x to the 3rd, y to the 3rd. Is there a common factor? Okay. Does 6 go into each one of those? And the answer is yes. Is there a common variable? Do they all have x's? What power can I take out? 3. And what power of y? 3 also. So it's going to be very small when I write this, but I'm going to divide each of these by 6, x to the 3rd, y to the 3rd. And that gives me 6 goes into 54 9 times, x to the 6th, y to the 5th. And how did I get those exponents? I used the quotient rule. 9 minus 3 is 6, and 8 minus 3 is 5. Minus 24 divided by 6 is 4, x to the 4th, y to the 3rd, plus 18 divided by 6 is 3, and what happens to those variables? They cancel out. I did not learn how to factor anything by trial and error that looked anything like that, so I assume that problem's done. So that was just common factor. 49. I have 5x to the 3rd plus 15x squared y minus 50xy squared. Is there a common factor? 5. Is there a common variable? X. Isn't there an x in all of those? So I'm going to divide 5x into each one of those. And what will that give me? It will give me x squared plus 3xy minus 10y squared. Does this trinomial look like anything we've factored?
Yes.
And it does. We have an x squared on the front, we have a y squared on the back, and we have an xy in the middle. So I will make sure that I keep my 5x, and I'm going to try some trial and error. What will the signs be since the last sign is a negative? One of each. Good.
Can we use that sheet on our test?
The sign pattern sheet? Yes. So if you have the sign pattern sheet, you may use it. Those of you who go on to intermediate, you won't be able to use it in there. It's a whole new blue sheet and new things to be responsible for. Okay, so I have x and x. And by the way, that sign pattern sheet, you can print it off of handouts. All right, I'm going to need factors of 10. Oh, by the way, how about if we sneak our y's in there so we don't forget them? I need factors of 10, which because the signs are different, have a difference of 3. What will they be? 5 and 2. And I need the big one to be positive like the middle term is, so I'll use 5 and 2. Be sure you check it. The outer product is negative 2y. Negative 2xy. The inner product is 5xy, and that gives me positive 3xy. So when I was working on figuring out the factors of the 10, 1 times 10 would not give me a difference of 3, but 5 times 2 did, and that's why I chose 5 and 2. Number 50. I have z squared minus 8z plus 16. Oh. I am just not good at that. All right, there's no common factor. It is a trinomial, so I go straight to trial and error. If the last sign is a positive, what does that tell you? Both of them match the middle term, so they're both minuses. I need a z and a z. Factors of 16, which since the signs are alike, add up to be 8. Is it 1 and 16, 2 and 4, or 1 and 8? I'm sorry. I can't even multiply. I'm looking at the wrong number. 1 and 16, 4 and 4, 2 and 8. I apologize for getting off track there. It is 4 and 4. I know I'm tired. You're tired. This is a long review. Oh, yes, I do. Yes, I get to repeat this for my next class. All right, I have 5x squared minus 25x plus 30. Is there a common factor? Yes, there is a 5. So if I divide each of these by 5, that will give me, in parentheses, x squared minus 5x plus 6. Does that trinomial look like something I've worked on before? Yes. Keep the 5. Don't lose it. If the last sign is positive, what does that say the two signs down here have to be? Both negative. So I have an x and an x. I can either use 1 times 6 or 2 times 3. I need their sum to be 5. 2 and 3, it doesn't matter what order you put them in there. Number 52. I have 8x squared minus 8x minus 48. Is there a common factor? 8. If I divide 8 out of those, in the parentheses, I'll have x squared minus x minus 6. Keeping the 8, I have an x and an x. Since the last sign is negative, what kind of signs do I get? One of each. Now, that's 1 times 6 or 2 times 3. This time, because the signs are opposites, I'm looking for a difference of 1. What do I choose? 2 and 3. I want that difference to be a negative 1. So the big number has to go in the negative spot. And although I have not done it on all these problems, please always double check your inners and outers. Negative 3x, positive 2x does give you the negative 1x. If you had it and you got positive 1x, you'd know to change your signs. And the last problem is 20x squared plus 24x plus 15x plus 18. There's not a common factor. I see 4 terms, so this is my chance to do some grouping. First group, second group. What's in common in the first group? 4x. 4x will go into both of those. 4x goes into the first term 5x times, and 4x goes into 24x 6 times. What's in common in the second group? Okay, and it's a positive 3. 3 goes into 15x 5x times. 3 goes into 18 6 times. I must be doing this right because I'm getting a common binomial factor. I like to factor that out and put it in the front. And what is the leftover factor? 4x plus 3. And you can check it with FOIL. Remember, there are only 33 questions on the actual final exam.